Hello everyone, welcome to 10-Minute Physiology. In today's video, I'm going to give you a short introduction to the physics of sound. Now this video is not really going to be comprehensive, so please don't use it for a physics class, but it's just meant to give you a background to the important information and the basics that you should know in order to understand our sense of hearing. So with that, let's give it a go. So the first thing we have to talk about is the two different types of waves that we see in physics. The first type of wave looks something like this. And this wave is something called a transverse wave. So what is a transverse wave? A transverse wave is a wave that travels at a right angle to the direction of the disturbance. An example of a transverse wave would be electromagnetic radiation. The second type of wave sort of is hard to model on a piece of paper, but it sort of looks like this. And it's called a longitudinal wave. So a longitudinal wave is a wave that travels in the same direction as the disturbance that caused it. Now, longitudinal waves move through a medium from the point of disturbance in the form of compressions followed by rarefactions. So what is a compression? So a compression is basically where the particles of the medium are bunched together. So in this particular wave, we see two compressions. The first compression is here, and the second compression is around here. And we also have rarefactions, and this is where the particles of the media are far apart, which is what we see towards the middle of this wave here. So which of these two waves do you think is a sound wave? Is it a transverse wave or a longitudinal wave? Well, sound waves are longitudinal waves. So now that we know the type of wave that sound waves are, let's talk about the properties of waves. And what we're going to do is we're going to use a transverse wave as a model just because it's a little easier to visualize. So the first important property of waves is the wavelength. So the wavelength is basically the distance from peak to peak or from trough to trough on a transverse wave. And in a longitudinal wave, the wavelength is equal to the distance between two compressions. So that is what the wavelength is, and that's the first important property. The second important property is going to be the amplitude, or the height of the wave. Now, the amplitude is incredibly important because this is what's going to be proportional to the intensity of the wave. The greater the amplitude, the higher the intensity. Now, the next property that we're going to look at requires another wave in order to compare this blue wave to. So let's draw another wave. Now, the first thing that you should notice is that this wave has 3 peaks, whereas this wave has 2. Now, note that both of these waves occur across the same time interval. So both of these waves, let's just say, occur across 2 seconds. And over the course of 2 seconds, this blue wave has only 2 peaks, and the green wave has 3 peaks. So what's going on here? Well, the first hint is to look at the wavelength. So the wavelength of this green wave is actually a little bit smaller than that of the blue wave. The amplitude is the same, but it's the wavelength that basically allows this extra peak to take place. And this lower wavelength corresponds to the frequency of the wave. So basically, the higher the frequency, the lower the wavelength. And this is because frequency and wavelength are inversely proportional to each other. So with that, let's now talk about what frequency and period are. So what is frequency and period? Well, frequency and period are related to each other via this equation. So T represents the period and F represents the frequency. And what you should see here is that they're inversely proportional to each other. So the frequency is basically the number of complete wave repetitions per unit time. And the period is the smallest time interval required by a wave to complete a wave cycle. So in other words, what we see from this relationship here is that the higher the frequency of the wave, the shorter amount of time it takes for a wave to complete a wave cycle. So in other words, the higher the frequency, the lower the period, which is what we see from this particular relationship. And that's an important relationship to remember. So now let's talk about the decibel scale, which is incredibly important for humans. So the decibel scale goes off of this equation here, And what we're going to do is we're going to identify what each of these variables are. So dB represents decibel, and the two i's represent two things. The I on the numerator represents the intensity of the sound, and the I sub 0 represents the threshold of human hearing, which is equal to 10 to the negative 12th. So in other words, it's a logarithmic scale comparing an incoming sound wave to the threshold of human hearing. The louder the sound, the greater the amount of decibels the sound is. And that's incredibly important to understand as well. So this equation expresses the intensity of a sound wave on a logarithmic scale. Now the softest intensity we can hear is 0 decibels. Hearing loss starts to occur once we hit 80 decibels. However, this depends upon the time of exposure. For example, if you're exposed to 80 decibels for 2 hours, then what can happen is you can start to have possible hearing loss. And as we increase the amount of decibels, the amount of time that's required in order to produce hearing loss also decreases. So compare this to 110 decibels, where it only takes less than 2 minutes for damage to start to occur. So this decibel scale is incredibly important to understand. So the last thing that we're going to talk about is the application of all these things to sound waves. So we've been talking a lot about frequency, wavelength, period, amplitude. Now let's apply these things to sound waves. So the pitch of a sound is going to be proportional to the frequency. So the higher the frequency, the higher the pitch. Now the loudness of a sound is going to be proportional to the amplitude. So the higher the amplitude of the wave, the louder the sound is. So this is incredibly important to understand as well. So now let's apply what we learned to longitudinal waves, just to see how the wavelength looks in these waves in case you didn't understand it. So this right here is our first longitudinal wave. And what we see here is two compressions, as we see right here. And the distance between these two compressions is the wavelength. Now, if we were to compare this to another sound wave, what we would see is something like this. And what we see here is that the difference between the two compressions is decreased, so the wavelength is smaller. So using our relationships, what we should understand here is that the frequency of this particular sound wave is going to be greater than this one. So that this one has a higher frequency, a higher pitch. So this would be a higher sounding sound. So that's it for this video. I hope it helped you get a basic understanding of what sound waves are and the different properties of it. And I hope to see you in the next video. Thank you for watching, and I hope to see you next time.